Okay, let's finish talking about behavior near an asymptote. We're really talking about behavior near the vertical asymptote because if you notice, on one side, the arrow is pointing up along the asymptote, and on the other side, the arrow is pointing down along the asymptote. So we want to describe both of those things. So what we say about this is as we get close to the asymptote, in other words, as x gets close to 6, and there's two ways to talk about it. One's from the right and one's from the left. So we have to write two different statements. As x gets close to 6 from the right, in other words, on the right side of the graph where this green arrow is, so I'll highlight that in green, as x gets close to 6 from the right, the arrow is pointing up, so y is going to infinity. And as x gets close to 6 from the left, this blue highlighted arrow is on the left of the asymptote, so I'll highlight this one in blue. As x gets close to 6 from the left, that arrow is pointing down, so we say y goes to negative infinity. And that's behavior near a vertical asymptote. Let's look at the next problem in the examples. Y equals negative 3 divided by the quantity x plus 1 minus 5. So when we go to graph this, it's the same kind of thing as last time. We can identify the vertical asymptote first. X can't be negative 1 because we'll get 0 in the denominator of x is negative 1. So right here, there's a vertical asymptote at x equals negative 1. Also, a fraction of this form can't be 0, but it's going to get really close to 0. 0 minus 5 is going to give us negative 5. So down here, 1, 2, 3, 4, 5 is the horizontal asymptote, y equals negative 5. And so we're going to do everything from the center point there. And the stretch this time is negative 3. That means if we go over 1 from the asymptote, from the center point, we got to go down 3. 1, 2, 3. So that's going to be our first point on the graph. And if we go to the left of the asymptote 1 unit, we've got to go back up 3. 1, 2, 3. So that's another point on the graph. And that's going to help us identify where the curve is. You notice now the curve is not going to be in this space because there's no points there. The curve is going to be down in this space. So it's still got to get really, really close to the asymptote. But it's going to go down the asymptote on that side and up on this side because it's got to go through those points and never touch the asymptotes. So in terms of the features, we have the domain is all real numbers except for negative 1. So we say x is not negative 1. The range is all real numbers except for negative 5. So y is not negative 5. The y-intercept is what happens if we plug in 0 for x. So y equals negative 3 divided by 0 plus 1 minus 5, which is going to be negative 3 divided by 1 minus 5. Negative 3 minus 5 is going to be negative 8. So it's 0, negative 8, and we had that one right here from our earlier discussion. Our asymptotes are y equals negative 5 and x equals negative 1. Our end behavior, as x goes to infinity, in other words, if we're over here on the right side of the graph, the y is leveling off at negative 5, y goes to negative 5. As x goes to negative infinity, y is going to negative 5. That's the whole purpose of a horizontal asymptote. It tells us how close we're getting. It tells us where we're going as x goes to infinity and negative infinity. And then the behavior near the asymptote, let's see, on the right side of negative 1, we're heading down, and on the left side, we're heading up. So we write as x goes to negative 1 from the right. You got to tell which direction. Y goes to negative infinity. That's the green side. As x goes to negative 1 from the left, y goes to positive infinity. And we'll do the next example in another video. Thanks.